Hi, my name's Mark Raval, and I'm here to talk about the new HybridCache API that we're introducing in .NET 9, in particular with ASP.NET Core, but it works in all your applications. So, with any new API, the first question is why? So we're going to discuss that first, and then in order to put that in context, we're going to have a quick recap of the existing caches, how we use them, and what their limitations are. Again, looking at why we need a new API in HybridCache. Then we're going to have a look at HybridCache in use, see how it simplifies our code, see what new features it brings us, and then I'll wrap up with a summary of the features that we're adding and the direction that we're going to with this new API. So, why are we adding a new API? The existing cache APIs, they work, but they're very hard to use well, and in particular, they're hard to use efficiently. The two main APIs that we'd be talking about there are IMemoryCache and IDistributedCache, and both of those have great features, but they also have limitations and pain points that make them awkward to use in most common scenarios. But also, your code ends up writing a lot of the things itself. The libraries do very little internally. So what we're trying to do, since cache is so important, is make it really easy to use cache well. And in particular, the most obvious code that you can write should work efficiently and well and correctly without you needing to worry about all those details. So, first thing I can do then is to show an example using IMemoryCache as to what your existing cache applications might look like. So I have over here a fairly standard .NET 9 application, web application, and it's very, very simple. I'll show you in a moment. But in particular, in the first version I'm going to show, we don't have any caching. So basically, I've got a single web page that talks to a simulated service that very deliberately just takes 2.5 seconds to invent some data. In the real world, we could be talking down to a SQL database or to some large language model, HTTP, gRPC, some expensive resource. Whenever we're talking about caching, we're usually talking about some expensive resource. So I've got a simulated data query that's expensive. So I've started the application, and now if I switch over to a browser for this web application and just refresh that, you can see the traffic start down here. And you can see we've got a simple page here that took roughly 2.5 seconds, and all it's done is generate a GUID. And because we've got no caching, if I refresh that page, every time I refresh it, I'll get a new GUID down here, and it'll take 2.5 seconds. So that changing GUID is making it clear that we're doing new work each time. Now, obviously, taking 2.5 seconds isn't great. And performance is important in any application. So what we're going to do is we're going to add some simple caching to make this page run quicker. And the simplest way to do that is with IMemoryCache. So if we go back to our application, if I look at the original code that's just calling that underlying data fetch, what I'm going to do, I'm going to switch to a different implementation, which uses, so this one requests IMemoryCache as a service. And in that same operation, when we get the expensive data, we're going to use MemoryCache. So to use MemoryCache, first of all, we need a unique key for our query. And since this is a parameterized query, we take in an ID here, we're going to build that ID into our key. And MemoryCache basically has a get API and a set API. So we're going to ask the MemoryCache, do you have this value? And if it doesn't have it yet, then we'll do the work to go down and perform the expensive operation and set that into the cache. And then whether we did that work, this request, or whether we got the value out of the cache in this try get value, we'll then return that back to the caller. So the way I've got this working, all I need to do to change the implementation that we're using is to come in and tell it to use this with MemoryCache implementation instead of our some backend data service. And if I save that and restart our application, And when that's going, I'll go back to the web application. Now, if I load the first page, we expect it to take 2.5 seconds because we haven't. The first page needs to be, so we still need to do the work once. But now that I've done that, I can run it a few times, and now it's taking 0 milliseconds. And importantly, obviously it's just expired. Now, when it's taking 0 milliseconds, I'm keeping this ID. So that means we're not doing any extra work. We're just getting that value straight out of cache. And that'll last for a few seconds. I think I've got it configured for about 10 seconds before it has to do the work again. So that's IMemoryCache. But the limitations of that is, of course, that's just running in process memory. So if we've got any kind of cold start, so the application recycles, or if we have multiple nodes, we can get into various problems, either with an inconsistent cache where as a consumer caller bounces between different websites, they get different values, or we can get into the situation where it looks fine until everything shuts down, and then all of a sudden the entire site takes ages to start from a cold start. So that's IMemoryCache. It has limitations, but you can use it. It's relatively easy to use. There's another big limitation, which is there's no serialization going on here. It's actually handing back the exact same object that you give it. That is a good thing. It doesn't have any overhead, but it's also dangerous because if that object is mutable, so if you can change anything on that, you could then be handing out that same object to lots and lots of requests. And if they make changes to it, obviously they're going to be changing the value that's live in the cache. So that's IMemoryCache. Again, very simple to use there. We just register it with add memory cache, and that's the same code we just looked at. There's one other thing we need to be really, really careful of when caching, which is stampede. So what's that? Normally, if we just have one request come in and we get a cache miss, so that value isn't around, that's fine. We'll just pay the cost, we'll go down, do the work, store it into cache, and everything's fine. But if we're on a really, really busy site and all of us, our cache expires, we suddenly get the problem where we could have 10, 20, 200 requests, all requesting that same bit of data and all getting a cache miss. And when that happens, if we're not careful, all 200 of those requests can end up doing the expensive operation, which obviously is going to have a lot of overhead on your underlying system. And you can also get the problem where they then do the work of storing that work into the cache. So what does that look like? So if I go back to our website here, and it's a cold situation at the moment, all the cache has expired. So if I quickly run this from 3 tabs, you'll see all 3 of these, they've all got different IDs, so they've all done the work, and all 3 of them took 2.5 seconds. But now that we've initiated the cache, it's nice and fast, and they're getting the value out, so that's great. But when we were under load, we were under a lot of pain there, and that can really hurt systems. And that's something we might want to avoid. So that's IMemoryCache. The next thing we might want to look at in the existing systems that you're familiar with is IDistributedCache. So what's IDistributedCache? That's a similar API to IMemoryCache, but now we're talking about out-of-process stores such as Redis, SQL Server, SQLite, Garnet. All of the, it could even just be a file system. Anything that lets us store data outside of the process. Now that has 2 great advantages in that it means that if we do a cold start, the out-of-process data might still be available, so we don't have to pay that cost of just because we restarted the service, we have no cache. And the other thing is, if we're using a central server for that, again, usually things like Redis, we can then have a consistent data store for our cache. And configuring that, we're getting quite a bit more work now, but it's a very, very similar concept. We create a key for our data with our unique ID, and call into the distributed cache has got a similar get API. If the data isn't there, which we can tell by the null, then we need to go and do the work. But now we need to actually store it back into the cache, which means we need to serialize it through some serializer. Could be JSON, could be XML, could be protobuf. And then we need to store that data into the cache. And But if the data was there, we need to do the opposite. So we need to deserialize those bytes that we got. So we're starting to do quite a bit of hard work here. But it's relatively easy to set up. So now that I've changed the service, I can restart the application. Where's my build error? Build error is in program.cs. Oh, yeah, my bad. So if I run that, restart our application, and what I can also do is, because we're talking to Redis, this view over here shows Redis traffic. And again, I can bring up our web application. And now you can actually see some Redis traffic coming in here. So the first time we did a hit on the page, it went down to Redis to see if the data was in there. Took 2.5 seconds to do the actual work. Then it pushed the data back into the Redis. And we see that go again if I do a slow page. But now, if I keep refreshing that, we're getting the 0 milliseconds, but you can see it's going down to Redis each time to get that data. So overall, relatively easy to set up. But now we're paying the cost of latency and bandwidth down to Redis each time. And we can also get into a lot of problems if our Redis server becomes unavailable for any reason. We're migrating the Redis cluster or something. And the IDistributedCache API plus serialization can also add quite a bit of overhead in terms of byte arrays and things into our request. So very nice, clean API, really, but it has some pain points. What HybridCache is meant to do is to bridge all of these advantages. So let's go and have a look at what we can do now. What we really want to look at is this new API, HybridCache. So let's have a look at that. Because this is a new API, what we need to do is add a new package reference into our project. So you can see here that I've got a package reference to Microsoft Extensions Caching Hybrid, which is the new NuGet package that's hosting this at whatever the current version is. And if I go to our program, CS, when I'm registering, I'm going to add in, call this add HybridCache API, and that's going to register this new HybridCache service that we can use in our application. And there are various options that we can pass in on this. All I'm going to do for now is just set a default expiration to the same expiration that I'm using in the other places, and that's just going to simplify our code. There's lots of other things we can do configuration wise. I'm not going to cover all of those here, but the other thing, of course, is to switch our implementation to HybridCache. And if I go and look at what that one's doing, now we can see this is a lot less code. So HybridCache, we still have to come up with this unique string that's going to represent our key for the cache. But rather than having a separate get and set API, HybridCache uses the pattern that already exists in some other cache mechanisms, where we can do this get or create async method, where we pass in a callback to execute if the data isn't already there. So that's really, really simple, because all we need to do is say, I want to use HybridCache, get me this data, here's the key, here's the operation to perform. So I want to call down to the same expensive operation that we had before, forwarding the cancellation token that we've got. And if I restart it, it's still going to take 2.5 seconds to do the first page, because we still need to do the work once. But now, if I do these other pages, they took 0 milliseconds, so they haven't done the work, and they've got the same GUID. So we know for sure they haven't done the work. But you'll notice on the left here, it didn't do any Redis calls. It stored the data down, but on a per page basis, we haven't done anything unless I let it expire. And again, I can just go through these, and they're going to take 0 milliseconds, and they're not doing any traffic down to Redis. So the way that works is HybridCache basically brings together the IMemoryCache API for in-process memory and the IDistributedCache API for out-of-process memory, and takes care of all the other things for us. So it deals with the serialization, it deals with various other key validation, things like that. But importantly, we've got one other thing that it does that's really useful, that is the stampede protection. So if I quickly refresh all of these pages, again, they're taking 2.5 seconds that you might expect, but rather than each of them generating their own work with the 2.5 seconds, we see that they've actually all generated the same GUID. And what's actually happened there is the HybridCache library has detected that we've got 3 requests all querying the same data that isn't currently available. So it's combined those, and it's only done the underlying work once, and it's queued up the other requests so that when the data comes back from that one operation, they all get that result. So that significantly reduces our overhead when we're under a heavy load and we get a cache miss. So if I run that again, we'll get the pay the cost the first time, and then it all just works for free. So it's really, really simple to set up and very easy to work with. Behind the scenes, it's using JSON serialization by default, but that's fully configurable. So if you have types that might work better with protobuf or XML or any other serializer, we can configure all of that. So again, really, really easy to set up. We just add in the HybridCache package, call add HybridCache, and then most of the work is just hidden behind this get or create async method, making it really, really simple to get all of the right behavior by default. And if you're worried about the delegate allocation and capture, there's also a secondary API that allows us to pass in a state to hand down to our callback, so that we also don't need to pay the cost of a capture context if you're in a really, really high throughput scenario. But for most purposes, the simple API where we just give it our async callback, that's going to be absolutely fine. So that's the core parts of HybridCache. It's a new cache API. It's releasing alongside dotnet 9. So what do I mean by that? Is that it's not just targeting dotnet 9. So if you've got an existing dotnet 8 application, whether that's for long-term support or a dotnet framework application, you should be able to use this API. It's much, much simpler to use, and importantly, you're much simpler to get right. And as we saw, we get the stampede protection. And as we discussed, this now gives us much more predictable behavior if the backend cache becomes unavailable or anything else untoward happens. Lots of exception handling built in so that the cache isn't going to break your application if there's something that comes in. And we're also making use of new APIs. So there's a low allocation API, very similar to IDistributedCache, that is available on some backend providers. So we've built this into the SQL Server backend cache and the Redis backend cache, and we would like to help build those into any other IDistributedCache implementations that people are using, whether that's Cosmos or SQLite. If we can help with that, I'm more than happy to jump in there and see what we can do to help. It's not a complicated API. So we've also got a lot of configuration points in this API, including the ability to fully configure serialization, either on a per type basis, or if you've got a serializer that handles some family of types, it can handle all Google protobuf types, for example. That's really easy to configure. And we've also got observability built in, so that's all of your standard events and counters, ETL, that should just work. Another new feature that we're adding is the ability to invalidate data based on tags. So if you've used output caching, you'll be familiar with this. So when we actually add things to the cache in the get or create API, I can optionally specify one or more tags, which are just string tokens that map to whatever your domain is. For example, you could in a sales application, you could tag data that's in the the special offers, and then if you want to reset all of the data associated with special offers because it's Black Friday or whatever, you can just run a command to invalidate all of the data associated with a specific tag, and at a single moment, all of that data will become invalidated in one go. Much more efficient than having to know all your keys to invalidate. We're also looking at back-end assisted cache invalidation. So obviously we've got the problem if you've got an out-of-process cache and an in-process cache, making sure that if you want to forcibly invalidate the out-of-process data, that gets into the in-process data ASAP. That's won't be in the .NET 9 initial version, but we're looking to add that as soon as possible. And importantly, what we're adding here isn't just a new API, it's a whole new abstraction. So yes, when you call the add HybridCache registration, you're adding the default implementation, but because it's just an abstraction, other people are free to also implement that API. And so I know Fusion Cache are looking to add an implementation with their own features, which that we may the inbuilt option may have features we don't support, and their implementation may have more other features. So you got lots of options there. So that's the main overview of HybridCache. Obligatory download .NET 9 slides. There's a bunch of links there to the documentation that exists on learn.microsoft.com, the NuGet package, and the GitHub repository and the demo code. Just to clarify in terms of timescales, this API will still be preview when .NET 9 lands. It's in the .NET extensions family of libraries, so this will be shipping in the 9.1 release of .NET extensions, which is likely to be very soon after .NET 9. I can't commit to a specific date there, but you can play with it now, but it'll be GA in the 9.1 release of .NET extensions. That's pretty much it. If there's any more questions on this topic, please feel free to ping me either on Twitter or directly, and I look forward to hearing what you can do with this API.